All right, we're going to start this little short video today. And in the last few days of this distance learning course, we're going to take a look at a couple of different ways to display the data, share the data that you've gathered with other people. It also helps in the analysis of the data too, if you think about the role of the statistician. So one way to start analyzing the data to kind of see it visually or display it for other people is to use a stem and leaf plot. And I know some of you have worked with stem and leaf plots in the past. Sorry, I'm moving my computer. But I wanted to take a minute or two here to talk about them as maybe a review for some of you. I'm going to see if I can reduce that. There we go. Okay, stem and leaf plots. No, we're not talking, whoops, sorry. No, we're not talking about that kind of stem and leaf here or here. We're talking about this type of presentation of data. I personally think that this example of a stem and leaf plot is pretty poor. Poor because every stem and leaf plot should have a key that explains to people who are looking at the stem and leaf plot what the data really means. For example, now are you listening carefully? I want you to hear the vocabulary that I'm using. A stem number of 17 and a leaf of 8. A stem of 17 and a leaf of 8. I don't know what that means. I should see a key that says this, a stem number of 17 and a leaf of 8 means 17 feet, 8 inches. If I saw this key, then I would know what all of these other numbers mean, right? I would know that a stem of 14 and a leaf of 9 means 14 feet 9 inches. And I would actually know that 3 of these boys in the long jump jumped 14 feet 9 inches. Here's a better stem and leaf plot. I ran off the bottom of the screen there. Here's a little bit better one that I can see the key right here. A stem of 6 and a leaf of 3 represents a 63-year-old. So now I know that there was a 31-year-old. Actually, there was another 31. Oh, there were 3 31-year-olds. There was I'll change colors. There was a 52-year-old and a 66-year-old was the oldest person. How are we feeling? Okay, stem and leaf plot. Sometimes in the stem and leaf plot, some mathematicians, I don't usually do this, but they split the stem. When it looks like there's going to be too many leaves piled out here on the stem, hooked on the stem at 3, sometimes the mathematician, statistician split it. It looks like this person split it so values from 0 through 4 would be on one part of the stem and 5 through 9 would be on the other part of the stem. You can kind of see it here too. 0, 1, 2, 3, 4 are on one part of the stem, and then 5, 6, 7, 8, 9 are on another part of the stem. I really wish I would declare, if I was the god of statistics, that there should be labeled like this on the stem. Here's a better example. Someone's explaining. Here's a stem and leaf plot with no split, that the leaves, no matter what the value at 0 here, did you notice they're in numerical order? And you should do that in your stem and leaf plot. Order the leaves, put them in order. Notice the smallest value is closest to the stem, and then the values grow as you get further away from the stem. And you can see that this data has been split into two parts over here because whoever did the one on the right must think that there's going to be, they don't like it when there's so many leaves piled up in one area. Totally optional, and you get to decide as the statistician. Well, again, there's no key here. I have no context of what this data means, but I do see there's boy leaves and girl leaves, and but I don't know what it means. So you should have a key. I love this example, even though at the bottom I said, oh, we ran off the bottom of the screen a little bit. I don't like it. The one thing I don't like is there's not a key, but I think we can figure this out. You know those candies, Smarties, whoops, sorry, let me pull that back again. Those candies called Smartie, those super sour little discs in a cellophane wrap. I'm imagining there was a class of students and the teacher gave each student a box with a bunch of those Smarties in it and had them look inside and guess how many Smarties are in the box, right? And then later on go back and actually count how many are in there. So now let me ask you a couple questions. Hey, pay attention. You're looking at the graph, right? Okay, so what was the lowest guess that any student made of the number of Smarties in the box? The lowest guess. I'm going to go with my interpretation here is 21 was the lowest guess. Notice there's no leaf up above it on the stem at 1, and there's no leaf there. So I don't think there's anybody guessed in the teens. I think 21 was the lowest guess. What was the highest guess? We can see that down here, right? Whoops, sorry. We can see it down here at 61. What was the highest number of Smarties that was actually in the box? The greatest number of candies in the box? Yeah, right, 59. 59, do you see it? 59. And actually that happened 59, and that happened twice. There's two 59s. And I would say the mode here, the most common number of Smarties in the box was 54. And that happened a whole bunch of times. That's a split stem and leaf. Here's some data that's in a stem and leaf plot, and there's no key, so I'm going to add a key and say a stem of 2 and a leaf of 1 represents 2,100. 2,100. Now that we know that, can you list all the numbers in the data set? You know, what would a stem of 1 and a leaf of 0 mean if this is the key? Wouldn't it be 1,000? And what would a stem of 1 and, whoops, let me move that out of the way. What would a stem of 1 and a leaf of 3 be then? Pretty sure it'd be 1,300 and so on. And it'd go all the way down to, let's see, a stem of 5 and a leaf of 8 would be 5,800. So that's what the data really looks like. The only difficult thing about a stem and leaf plot, as long as it has a key, is, and you got to remember to use a key, is determining what the stem looks like. I'm looking at this data here, and it ranges from 85 all the way up to what? 132? And I've got to put that data on a stem and leaf plot. If this was me, I feel like doing this, going 8, 9, 10. Now I have to number consecutively, even though there's no numbers in the 90s, I have to number consecutively. And what was my biggest number? 132. So I'd go to 13. And then at the stem at 8, I would put, and I'm going to cross it out, 85. And the stem at 9, there wouldn't be any numbers. At 10, there's a, I'm going to put a 0. That's the number 100. There's also a 101. 10 and a 1 with a 101. And I think that's it there. At 11, which would be 110, let's see, are we in, what do we have in the teens here? 114 and another 114, 114, 114, there's the 114s, and a 118, 118. There's a, whoops, I missed the 117, didn't I? Dang. Well, that's why we do these in pencil, but I'm lucky I can move that over. I cheated. Whoops. I cheated, but I got it to work out. So put the 7 in there, and then we'd have the 122 and the 132, right? And I think I've got all the data there. And then on all stem and leaf plots, you put a key. So I'd say, hey, a stem of 8 and a leaf of 5 represents the number 85. And now people know what all the data looks like. Hey, by the way, if the values have decimal points, typically in the stem and leaf plot, you don't put the decimal points. If I was doing a stem and leaf plot here, I can see the numbers and the 4s, 5s, and 6s. And let's see, at 4, what's the smallest number here? 4.2. I'd go 4.2 for 4.2. And I have a 4.3 and a 4.7. and a couple of 4.8s at 4. And then you could finish the stem and leaf plot. But then in my key, I'd say, hey, a stem of 4 and a leaf of 8 represents 4.8 seconds. And now I know what all the data would look like. So let's, by the way, one last one here. In the stem, if I was, oh wow, how would I do this? This is kind of the fly in the ointment there, right? I feel like I'd maybe just go 9, 10, 11, 12, all the way to, how far do I have to go? I got to get the 17. Okay, so I'd go like this on my stem, and then at 9, I'd put 40. That represents 940. And then at, what's next? At 12, I'd put 54. Do you get the feel? Then I can get the numbers on there if my stem is mostly 2-digit numbers. So that's stem and leaf plots. I mean, that's all there is to it. And the nice thing about the stem and leaf plot, it shows you, you can kind of visually see the middle of the data. Like here in this graph, the middle of the data was in the 50s, right? I can kind of see the middle, and I can also see, I'm trying to look for a good example. Don't really have a good example. And then I can see how spread out the data is also by looking at a stem and leaf plot. So it's a valuable tool, even though it's not high powered, not that difficult to do. It allows you to see the data visually. You can see how spread out it is. You can see the dispersion, and you can see where the middle, where the data tends to gather together. So it's a pretty powerful thing. And I just wanted to make sure we didn't slip through the cracks again and not have a chance to look at stem and leaf plots. So your assignment for stem and leaf plots, if you go into chapter 5, it's in chapter 5 in Schoology, in the probability and statistics course, and you'll see stem and leaf folder. And if I remember right, I'm pretty sure I do, the exercises that I assign are on an attached worksheet, and I'm asking you to do 1 through 4 on the front and 1 through 4 on the back. It's kind of worded strangely, but 1 through 4 on the front, 1 through 4 on the back. Stem and leaf plots. And that assignment is due tomorrow. So you have today and tomorrow to work on it. And then when we meet again next time, we're going to talk about the 5-number summary. See you then.